Welcome to the myprojectbazaar.com. This is our project title, a load balancing model based on cloud partitioning for the public cloud. This is the abstract of our project. Load balancing in the cloud computing environment has an important impact on the performance. Good load balancing makes cloud computing more efficient and improves user satisfaction. This project introduces a better load balance model for the public cloud based on the cloud partitioning concept with a switch mechanism to choose different strategies for different situations. The algorithm applies the game theory to the load balancing strategy to improve the efficiency in the public cloud environment. The load balancing model given in this is proposed system is aimed at the public cloud, which has a numerous nodes with distributed computing resources in many different geographic locations. Thus, this model divides the public cloud into several cloud partitions. Proposed a load balancing strategy based on game theory for the distributed system as a non-cooperative game using the distributed structure. This is a DFT of our process. Input of the process is a jobs, number of jobs 1, 2, 3 up to etc. After that, the jobs are arrived to the main controller. The jobs which arrive to the main controller are stored in the job list. After that, from the job list is nothing but like the queue. After that, from that queue we receive the job and get the job from the job list. After that, choose the cloud partitioning. This process are taken place by the main controller. The main controller first check which partition is in an idle state and which server present in a particular partition in an idle state. So the main controller perform this job. Choose the cloud partition first, then identify the cloud partition state. After that, if it is an idle or a normal state, if it is in a heavy state, it again moves to the next cloud partition. Otherwise, if it is in an idle state or normal state, just move that job to the particular cloud partition. After that, the partition balancer takes place. The job arrival to the particular cloud partition and the balancing process takes place. After that, we apply the scheduling process. We perform the scheduling process to allocate the received job to which server, that is the server which is in an idle state or a normal state. Then we assign that job to the particular server for processing. Let us see the demo of our process. First, open the NetBeans. Load balancing is our project title. Select find page.java. In this, we are going to act as a two role. One role is a cloud, another role is a user. First, we act as a cloud. In the cloud role, we should first create the cloud environment. Select the cloud. So, we dynamically partition as a partition 1, 2, 3, 4. We select the partition. Get details. After in the particular partition, there are 5 nodes present. Node 1, details, node 3, node 4, node 5. Likewise for partition 2. Details, partition 3, these are all the details of the particular node in a particular partition. So we finally create a cloud environment with 4 partitions. In each partition, it contains the 5 servers for processing. After that, now we are going to act as a user. In the user side, we should first enter the user ID. Enter the username. Then select the job. Select any type of job. The job may be any input file, maybe a PDF or maybe a text file or image file. Select text file. Send to the controller. Then we should separately run the main controller. So it receives the job sent by the user. Then now the main controller going to check the space present in the partition, whether the partition in a normal state or idle state or a busy state. After that we should separately run the one node. Node 1 status, node 2 status, node 3 status. Then for node 4 node status, node 5 node status, send it receive the status. Likewise for partition 2 run P2 node. Node 1 node status. If nothing in details is already stored in the particular node, it shows only the size is 0. Send, receive the status. Then next. Select the partition. The partition 1 means these are in the partition 1, these are the nodes are present. This much space is already occupied by the informations, that is a data present in that particular partition. This is the main implementation of our process. This is our algorithm implementation page. So totally 11 jobs are arrived to our cloud. In the 11 jobs, we are going to identify the users. These are the users of this 11 jobs. We can able to view the partition. For example, now I registered for a check balance. Store the data in the partition 2 and the node 1 successfully. Likewise, can check for any user. Can store data in the partition 1 and node 1 successfully. She can able to store the data in the partition 2 also, because the space is available in the partition 2 also. Partition 4. Was for check partition 1 to 4. Likewise, you can able to check for all the users. Based on this names and this jobs to the cloud, it balances the load. You can able to store the details in the partition 1, partition 2 or partition 4. Otherwise, if the size of the data is large, it is not sufficient. It is not of sufficient space in a particular partition. Means it allow a single partition to allow to store the data. Here our service is storing the input file alone. So by using the AND colony optimization algorithm, here we perform the load balancing process. Thank you.